Hello, and welcome to another episode. Here, we're going to start talking about the next concept, the next main concept we're going to talk about in Game 2, and that will be separating the network player and the game object. So I'm going to use the same project we had last time, so if you haven't finished that project, make sure you got that project working. If we recall, I'll just run a host, no client right now. And we have this little sphere we can move around, and then we can, if we get hit, so I click on it, we have our little HP down here. Nope. Yeah, HP is 10. And then if I get hit by a creature, a little red cube, my HP goes down by 2. So nothing really exciting. We're kind of exciting. We were able to prove that this worked on a client and a host. So it does work over network. Now there's a little issue with our design though. Our network player is also going to be our game piece. Now this makes sense in a certain circumstances, which we'll talk about in a minute, but it has its own host of problems. The first and most obvious issue is this object here is not only our character in our game, but also our primary interface through the network to interact with the server. Remember, we can only send commands on our network player. We are not going to use local player authority, so we will never have the ability to send a command on any other object than our network player. So if this object gets destroyed, we no longer have the ability to send commands. Now, it is possible to recreate a network player. It's very tedious and you have to be very, very careful, but it can be done. I do not recommend it as a viable solution, but again, it is possible. There's one direction you can go. So, but what we want to do is, if we want to destroy this piece, then the network player has to be a different object. Another issue we're going to have is if we had multiple objects, say this is like a real-time strategy game or something, we had 3 objects that belong to us, then this pattern will no longer work because we are only allowed to have one network player. Now, I'll be honest with you, if you have a game where your player is controlling one object and they have to die per se, one thing you can do, and it's not a bad solution, is to disable the renderer, make it, and then reset the location, reset the health, subtract 1 from, or add number of times you died, and after a certain amount of time, re-enable the renderer, and then the player has the illusion that their character died and they'll respawn. If your game works with that setup, that is a really good solution, and I would recommend doing it. But there are 2 limitations to that. One, you can, well, the biggest one is you can only have one player, one character, one piece, I should say, one game piece for each player. And 2, you cannot actually destroy the game piece. You have to send it somewhere or disable the renderer, and that will probably be, although not impossible, but you'll probably have to deal with that, like what that means, what exactly that means. So again, if you had normally I would say if you had a game where the player has one game piece they control and he gets killed or they get killed and they respawn, this would be a perfect solution. I would say go for it. However, again, there are a couple issues with that. We can't destroy the piece, 1, and 2, you can only have one piece. So for the rest of this semester, we're going to divide the network player and the game piece up into different components. On your own, again, having this algorithm where this player gets disabled and then re-enabled after a certain amount of time to pretend like it was been respawned is a perfectly viable solution. But for this class, for the rest of this class, we're going to separate these 2 characters, or these 2 objects. So we'll have a network player, which will end up being an empty object, and we'll have a game piece, which will control everything but the commands for the network, the game piece. And we'll talk about that. Okay, so what are we going to have to do here? Well, first we're going to have to make some more scripts. So I'm going to keep our network player script. I'm not going to touch that. I'm going to make a, what should we start with? You know what, I'll make a new network player. So we'll go here, we'll create C# script, and we'll say network player 2. And we're going to just start over. Pardon me. So here we're saying using Unity engine dot networking and network behavior. So nothing's going to seem too out of place at the moment. You'll see something's going to change quickly. But what we want to do is we want to remember modularity and start being very, very careful how we modularize our classes. Our goal for this, and I'm not even going to use update in this function, so we're not going to use update. One thing, our goal for this is to store metadata for the player, if you'll permit me the term. And this I mean team, points, lives, score, etc. This has to do with the player, not the individual pieces or piece of the player. Our goal here is also to handle commands. And this will act as a portal to the server. This is going to become very important later on. What else do we need to worry about? And possibly handle UI stuff. I would say this is only for the player, not for a specific piece. So if you want to do like a game piece's health bar, that should go on a piece. If you want to have a UI where you had buttons for different options, that would go here. So this is kind of our goal for our network player for the rest of the semester. So things like HP, speed, attack, etc. will not go here. What I may do, and we may just use this further on for the next example, we'll have string player name, word of warning, do not do this. What's wrong with this? You're actually overriding, the name is the name of the object, so do not do that. So I always tell the students to use player name. And let's see, I guess we could do points. Public int points. And both of these are going to be sync vars because they are important. The name should not be changing that often, so we're not going to add too much network traffic. And the points, although maybe adding significantly quicker, should still not add that many. Should still not have that much network overhead. If I could talk, it would be good. So really, we're kind of done here. I mean, this is actually all we need to do. I will say the player name right now is default name. Again, I think next tutorial when I do UI stuff, we'll do something with this variable. Now, this is one of the more confusing parts. Ideally, I say ideally because this is not how it's going to work out, but ideally this would handle only the player meta stuff, and the game piece would handle all the stuff for the game piece, like input, etc. Well, you have to remember that in order to change the game state on the game piece, I have to be on the server side. And the only way I can get from the client to the server is through a command. But the only command I'm allowed to run, or the only time I'm allowed to run a command in our setup without using local player authority, is in a network player. So here I have to break modularity a little bit. I have to go ahead and make a command. Now it's very tempting to do something like this. I'll bring back that update real quick. Oops. So it's very tempting to do something like this. If is local player, then we get our input input dot get axes raw horizontal, and then we send this to a command of some sort, and we move our player piece. I would recommend not doing it this way, because what's going to happen, apart from the fact you're using update, which is unnecessary, but what's going to happen is you're going to end up putting all of your game piece information in your player class, and this is going to become bloated and difficult to manage. So I would not put any control mechanisms or any update for the game piece in this class. The only thing this class is going to do is handle a command to get from the client to the server. And if you remember the PowerPoint, it's kind of a strange, but it's kind of a way to do it. But we have to get back to the same exact script on a different machine. So we're not going to actually do any input or any control in here. It'll make it more confusing, because you'll end up having to do two things in this class. You'll have to deal with the player information, and you'll have to deal with the input, and it'll just be messy. So the only thing we're going to do is we're going to have a command, and I'm going to mention kind of a cool way of doing this here. In fact, I'll do it now. Public void command move piece. So this is going to be called by the client and run on the server. And what we're going to do is we're just going to pass in a game object, my piece. And actually, I don't even need to do that right now. We'll take a float h and float v. And all we're going to do is call my piece dot move or something and pass in h and v. Again, this is going to be on the server side, so I will be allowed to move it. So all this is going to, so the game piece is going to call this command, and this command is just going to run on the server and then call the game piece that called it and make it happen. So here, the next question we have is, well, we have to spawn our player. So that's the other thing we have to do here, is we want to spawn our player piece. Also, respawn player piece if necessary, which can be non-trivial, but we'll talk about that in a moment. All right, so spawning the objects. We haven't really talked too much about spawning objects, so I'm going to start with the basics, and then we're going to go forward. I'm actually going, I'm going to do this a little bit later. We'll do public game object my piece prefab. Remember, when I send game objects, or if I send game objects in RPC or a command, then they have to be instantiated. They cannot be prefabs. Remember, the only way I can send a game object in a networking environment is because it has a net ID. So I recommend my students having a prefab tab or some sort of suffix or prefix, so they know that this is a prefab, and they cannot, under any circumstance, try to send this across the network. This will make a little more sense a little bit later. But just be aware, if you can send game objects that have a network ID and are instantiated over a command and as a parameter in a command or an RPC call, you cannot send prefabs. The damning issue of this bug is it will compile and it will run until it tries to send that prefab. Then you'll basically be sending a null. And it might even work on the host, but it will not work on a client. So going back here, we're going to make a new folder. Create folder my piece. So the rest of the semester, I'm going to use the following terminology. If I say game piece or network or player piece, I'm talking about the thing that's on the board, that moves around, the thing that's in the game. if I say network player, I'm talking about the invisible object that acts as a gateway. And we're going to call this game piece controller. Now, we're going to run into two problems here, and I will show you how to alleviate both of them. But it's crucial that you be very careful here. Using Unity engine.networking and network behavior. This is going to be the game piece code. This is the thing that controls the game piece. So we have I'm going to make everything public right now just so we can see it on the editor. Public int HP. I know I could use serializable too. Public int. Actually, I don't really care about anything else. I do care about one other thing though. Game object owner. Now this is the crux. This is the linchpin. This is how it's going. It all come together. The game piece needs to know. I don't know why is this not working? Hold on. My editor is doing something strange. The game piece needs to know what game object it's owning, or it's owned by. Okay, what am I doing wrong here? It's capital V. Okay, so we're going to have to worry about that. And we'll have a sync var for HP, so it'll keep track of the HP like we had last time. We are going to do a couple things. So I'll show you another pattern here. We are going to have a pointer to our network player script. I am trying to be consistent with my coding style. So we're going to have a pointer to our player script. Now, you cannot sync var a component. That's tragic because more often than not, it's not the owner object that we care about. It's the script, which we'll talk about in a moment. But we need to figure out, we need to have a pointer for this. And there's a way to do it. Now, a design pattern to be very, very careful. It's better, so you'll see when we spawn an object, we have to set the sync vars before we do the spawn. That's fine. But as far as populating the other variables, it's better to have the object itself be responsible for doing that than trying to have the network player populate these variables before it spawns. So a lot of people get caught up in this trap. So excluding sync vars, because you have to set these when you spawn the object, have the network player or the network controller, the game piece controller, be responsible for setting non-sync var variables. This also holds true to like setting colors, so maybe the team is a sync var, so that's set, but on start, have the game piece controller set the color. Don't try to set the color in a network player. You'll find that there's a lot more issues if you try setting colors or properties here than if you just have the controller be responsible for itself of its own object. Again, sync vars have to be set when you spawn it, so that's okay. We'll set those in network player, but everything else, the specific sprite, that specific animator, the specific color, the team name, etc. Set everything else in the network player object script. It'll just go easier for you. It's not impossible to set it here, but you can end up with some strange race conditions, because if it gets set on the host before this finishes loading, then on the client, then the client will not acknowledge the change. So it's just much easier to do the non-sync var changes and properties on start. And remember, right now everyone is running this code. So what I'm going to do is I'm going to assume, oh, the other good thing about this too is the sync var should be set once it's spawned, and this should have started after the sync vars have been synchronized. So here I should be able to say pscript equals owner.getComponent, and I don't know why my autocomplete is not working today. Network player 2, and that should set it up for me. Let's see if I can get this to acknowledge. My Unity is doing something strange here. Okay. That was interesting. Okay. Here. Okay, so now I have this set. The next thing I'm going to do is I'm going to start a slow update. I am not going to use update because there's no reason to, and now that some of this will be run on a server, in this case it will not be run on a server, but could be, it's better to try to minimize CPU usage as much as possible. All right, and then what we'll say is while true, wait 4 seconds, 0.05f. And I find this to be a pretty nice time, pretty nice interval. It's a little bit faster than the network sync, but it's not really wasting a lot. So now we have our first problem. The first problem is I want to do this. Well, what's the problem? It's a network behavior. That's fine. Remember, we are spawning this after the game started. This is not the network player. It's a network behavior, but not the network player. This will only be true on the server, because now the server owns this object. It's not actually owned by the network player. So this object is local player is actually only true on the server. And to be honest, I take that back. I'm not even sure if it would be true on the server if you were because I don't believe it would be tied to any player object itself. So I'm not even sure if that's true. But anyway, this will not work. So what we have to do is we want to say if the owner.pscript, or the pscript on the owner, is local player. Now this will be true whether we're a local player or not. So this is good. This is good. This is how we bypass one issue. Remember, we can no longer use local player on its own here because it will be false. The other thing we cannot do is we cannot invoke commands here. We can invoke commands on pscript, but we cannot invoke commands on the player controller. So the next thing we do is we'll do float h equals this dot get, or no, sorry, input dot get component. Sorry, get axis. I don't know why I'm having, it's getting late, I guess. Horizontal float v equals input dot get axis raw vertical. And now I want to run it on the server, but I can't call the command here. And I can't move the rigid body here because it's going to be a network transform. So here is the one point where we break modularity, and I'm going to call the player script dot command move piece and send in H and V. Now I could actually move the piece in this function, but again, that kind of blurs modularity, and I don't want to do that. So what I'm going to do here is I'm actually going to then, I'm then going to make a server-only function. So I know for a fact this will only be run on the server. And it will take an H, or a float, and two floats. And here I will have to use the rigid body, which I have not set up. So once again, I will set up a player or a public rigid body rig. And down here, again, everyone's going to have access to this, but we are not going to be able to, or we're not going to, only the server is going to use it. Let me see, did I use the optimization? Okay, no, I didn't. We'll talk about how to optimize this a little bit later. This is actually not very optimal because what's going to happen is I'm going to be sending the same exact command over and over again, even though I haven't changed my directions necessarily. So this isn't very optimal code, but we'll talk about how to make this called less. It's a little bit tricky, so we'll avoid it on this one. Right now, say myrig.velocity equals new vector. We'll send in h, v, and 0. So now you kind of see the issue here. It's kind of strange. I used my network player script to see if I'm a local player, get the input, call the command on my network player script. Then here I'm going to call my I guess I need to get the game object here too. Another thing you can do to make this more optimal, in fact I guess we'll just do it this way, is pass the game object in. That way you can pass multiple objects and handle multiple objects with the same command, which makes your life a lot easier. So what we'll do is we'll right here we'll call this .game object and pass that in, and that's fine because this is going to have a network ID on it, so that's fine. And now here we'll go back to network player and we'll say me.getComponent game piece, or my game what's this? Game piece controller. All right, sorry. I don't know why I couldn't remember that. Dot move. Again, I am now on the server, so I should be able to accept that. I have to make that public, don't I? I did. Okay. Dot move me, and I'll pass in HV. So this will happen on the server, which allows me to call move me, which will move my piece. So I am kind of going in this weird circle. When I have to get to the server, I have to go through this script, even though this script is not necessarily part of the game piece. That's why I'm trying to minimize what I do here and let the individual pieces handle it all. So this is an unavoidable issue to deal with. We have to go through the network player, but we don't have to store any of the other information of the game piece here. And that's the important and the critical part. Okay, so what else is going to happen? So now I have to spawn this thing. Okay, my mouse is not working either. Great. So we haven't not quite done yet. We're going to go up here, and now we have to spawn our player object. So I'll just do. Actually, we don't need an I enumerator right now. You'll see in a minute we'll need to use an I enumerator, but right now we don't have to. Spawn player piece. Now, this is how we dynamically spawn objects on a network game. First, we instantiate. Then we set all sync vars that need to be set. And we don't have to set them all, but the ones we need to set. And then we spawn the object. It's very critical that you do this, because if you don't, in this order, if you don't, then the spawning itself can end up in a strange erase condition or just not work. So the first thing we're going to do is we're going to say this dot or game object temp equals game object dot instantiate, similar to how we would on a single player game. And we can set, for now we'll just set 0, 0, or actually we'll just set nothing. So it should spawn at 0, 0, or spawn at this place. That's fine. And then we need to look at what our values are. So we have what sync vars. We have set HP and our owner. The owner is the biggest issue we need to set right now. Without the owner, we cannot do this. So we're going to say game piece controller equals temp.get component, which it should be on it. Get component. Got it. And player controller. Now, something I should mention here. Notice I create a temporary object to store this object, this new game object. I cannot store this in a sync var until after I've spawned it. So if I made like a sync var my piece, which is not necessarily a bad thing to do. So we have like sync var. In fact, I'll explain why in a moment. Public game object my piece. I cannot start with my piece here because it will not be instantiated on the network. After I spawn it, I can then set temp or my piece equal to temp, but I cannot just use game piece to instantiate it because it will not have a network ID yet. And you'll see that in a moment. So now we have to set our sync vars, only our sync vars. And then con.hp equals, I don't know, 10. After we've set, so here we instantiated the object. Here we have set the sync vars. And then finally, we are going to network spawn the object. To be completely technical, what's happening here is we're spawning this on the host. That's one thing I do to make sure this is a server only function. We're spawning this on the host, and then we are instantiating on the host, setting the sync vars, and then spawning it across the network. And we spawn it across the network by using network server. And the server will have this static object instantiated for it. And network server.spawn, and we pass in the object we created, which is temp. This is a little bit different than when I first released HLAPI in early 5.0. You did different procedures here. But so far from what I've seen, this works quite well. So the only thing else we have to do is we have to check to see if it's a server. Then we go ahead and we can say spawn player piece. So this also doing it this way also alleviates another race condition, because say I did have an update function here, and I did say, you know, get my piece or get my piece, and then try to set variables or check variables through it inside my update function. Well, in the update function, this piece may not have existed yet. Oh, and one other thing. So that can end up with an exception and a race condition. So doing it this way, where we handle all the input on the piece itself, will alleviate the most possible race conditions. And we can say my piece equals temp. Now we can set it to a sync var because we've spawned it already. If I had this line up here above it, it would break. So make sure you set game object to a sync var after you have done network server.spawn. So once this gets spawned, then this will kick in. Once I add some sort of input, it will send a command, and then the command will go to network player, which will then find out what object sent the command, then call that object's move me with the variables I sent and move the object. So this is kind of, again, a little bit, it seems a little bit out of your way, but this is the easiest and least likely to cause some horrible race condition or desynchronization in your game. So all you have to remember is just have a minimalistic command that gets your script or your command from the server or client to the server, and then let the server function inside the game piece itself deal with the gory details. This will make your life a lot easier. Okay, so once we have this script set up, we'll go back to our Unity. That was not Unity, okay. Now we have to make some more prefabs, so we're gonna make our little game object. We'll use a different 3D object now. We should use a cylinder. Yeah, we'll use a cylinder. Okay. And this is going to be our new object. And this is going to have the game piece controller on it. This is going to have the physics rigid body. We're not going to allow any rotation. We are going to allow interpolate. And then we are going to add a network transform on it. Sync that. We do not need any rotation. It'll alleviate. And we'll keep everything the same right now. Otherwise, we'll leave it at default. Now, there's one extra thing we have to do here, which I have not explained yet. But and we're going to call this game piece versus network player, and we make a prefab out of this. Now, this is not going to be a network player, so the server is not going to dynamically spawn that. So since we have to manually spawn this live on the game, we have to add it to the register spawnable prefabs. If you forget this step and you try it, you can get some weird error on the client, and the client's not going to see any of the new other players, and you've probably forgotten this step. So if any object, if you're doing the network server.spawn on any object, it has to go in this list. And you can add as many as you want, but you have to add the game prefab on this list, otherwise it will not work. So don't forget that. file save scene, file save project. Then we have to go back to our player, which I'm going to then make a new folder. We'll say player create folder. Okay, here. We'll create a new one. We'll say create folder network player 2. I know, 2 prefab. And now this is going to be the new network player. Here, we're going to have an empty object. So game object, create empty. We're then going to add our new player script to it. And we don't care about that right now or the points, but we do have to make sure we set my piece prefab here so we can know what player object we want to spawn. And that should be all we need. So we're going to call this network player. Two. Prefab. And we'll make a prefab out of this. Not here though. Oops, I just moved scenes. Sorry, my mouse is doing some really strange things right now. I apologize. Move network player prefab here. And then we're going to click delete this. And we're going to click on network manager and we're going to change our network player to be our new prefab. So we've added it to the spawn list. Good. We've added this, so this should spawn this. Good. Okay. So let's see what happens if I run this. Hopefully I've got it right. May have made a silly mistake somewhere, but we'll see if this works. Land host. Oh, I forgot to turn off gravity. So you saw it was spawned. It worked. It counts. I just forgot to turn off gravity. Pesky gravity. All right. And this is on a play. Okay, so. Okay, interesting. All right, what am I doing? So I'm not getting to my command. This is how you debug. You have to work backwards. So my slow update. I don't start my slow update. Okay. Oh my god. Oh wow. Okay. Sorry about that. Start coroutine. Slow update. Yeah, gosh, I wonder why it's not working. I'm not calling the command. Okay, yeah, don't forget to start your coroutine. I apologize. Okay. So now you see I'm moving my cylinder, and now my cylinder can be destroyed and I would still have a game piece. So it's not like anything would go wrong. If I click on, so here I get hit. I haven't actually inserted any destroy code, so it won't be destroyed, but you see my HP. Well, I don't have the HP code on this either, so it won't take damage right now. But if it did. So now I'm moving it around. Now, let's try it. Let's do it with a client. Notice one thing though while I'm moving it. See that the commands are being sent even though I'm not pushing any buttons. This is what I'm talking about as it being unoptimal. We'll show you how to make that more optimal soon. So here we're going to decide build and run just to show that it does work. So now we'll make this the host. And we'll make this the client. And we'll see that we have synchronization. And now, if for some reason a client object was destroyed, I would not be disconnected from the game. I could spawn another object, etc. So now I have the same functionality as I had last time, but this time the network player is just this invisible object that can't be destroyed, and my game piece, which hypothetically could be destroyed, is separate, and it can be destroyed and respawned if necessary. Again, for a game where you're only controlling one player and you want the player to respawn, this is over the top. You don't need to do this step. But for any time you need to destroy the game piece, or you have more than one game piece per player, you'll have to use this mechanism. And this is the best solution I've found, is to have just the commands on the network player and everything else on the game piece. It keeps your life a lot easier. So anyway, that's the end of this video. I'm sorry I forgot my coroutine. And then we will move forward with some UI objects and how to send player options into the game. Uh-oh, what happened here? There we go. And maybe some optimization tricks. And after that, we'll move forward with other stuff. Anyway, I will see you soon.